Hi guys, this is Avinash Sharma and we will discuss in this video the charts in the Python. All we know, presenting the data in the visual form is the chart in the Python, but that's not important like how to withdraw the chart and how to create the chart. But the important things, when a scenario is given, when the data is given to you, then how to decide which chart is the best for that kind of data. So this problem we will discuss in this video. For deciding the best chart for the data presentation, first of all, you have to find out the purpose of the data. What is the purpose of the data presentation? And for that purpose, you have to consider the basic 4 types of presentation type, like the comparison, composition, distribution and the relationship. So first of all, we check the comparison. In comparison means, say suppose you have a sales for the multiple years and you want to present the sales year wise, and just you want to find out the in which year the sales increase or decrease. But if there are only 2 parameters, then you can choose the bar chart. If there are the multiple parameters, it means including the sales, you want to find out the cost, then the profit and the manpower. It means you have the multiple parameters, then you can use the line chart. Now we check the practical with this program. So for the comparison, I told you like we use the bar chart or line chart, but there is a difference between the line chart and the bar chart. In case of the bar chart, if there are 2 parameters in this program, we have the sales and the year say multiple years, then we have the sales for respective years. So how much the sale was for the 2000, then the sales for the 2001. So this kind of comparison, there are 2 parameters, so we can use the bar chart. Okay, so in this line we are displaying the bar chart and we are using the year and the sales only. We are using only 2 parameters. Then if I run this program, then we have this bar chart. On the x-axis we have the year 2001, 2, 3 and 4. Then in the left side on the y-axis we have the amount of sales. It's a scaling. So you can see that in 2002 the sales was the maximum comparatively other years. So for this kind of comparison, if there are 2 parameters, then you can use the bar graph. But if there are multiple parameters, suppose including the sales, we also need to compare the profit and the cost for the year, then it means now there are multiple parameters, so we can use the line chart. Plot. So this is the line. So the red one is for this sales and the profit, the green one and the blue for the cost one. Now we can compare. So you can see in 2002 that was the sales and it was the profit and it was the cost. So in the line chart you can compare the multiple parameters. And the next one is the relationship. Relationship means like the one parameter is dependent on the other parameter. Suppose like you have a product and the price of the product is the 100 rupees, and on the basis of the 100 days you are selling the 1000 quantity of the product. But suppose you change the price of the product, you make it say 150 rupees, then the sales will increase or decrease. So for that kind of data you can use the scatter chart or the bubble chart. Again, if there are like few parameters, then you can use the scatter chart, or if there are the multiple parameters, then you can use the bubble chart. The one parameter is dependent on the another parameter. So in this program we have the 2 parameters, that is the product price and the sales of the product. So the sales of the product depends on the price. If the price increase or decrease, so also the sales of the product increase or decrease. If the price let's say 2.5, then sales is the 34, and when the price was 1.23, the sales was the 62. It means when the price was low, the sales increased. So if we check the program in the chart, that is the maximum sales. The price one was the 1.23, and when the price 2.50, the sales was 34 in red color. So this way we can analyze the relationship between the price and the sales of the product. And the next one is the distribution. In case of the distribution, we can use the scatter chart or the histogram charts. Sometimes we need the grouping of the frequency, or sometimes we need the grouping of the categories. So in that case we can use this histograms or scatter chart. If we check this program, so in this program we have the data for the ages. Now we have to find out the how many people are for the age of 60, then how many people are for the age of 20. So this kind of grouping of the frequency we can find out with the help of the histogram charts. So we are creating the histogram charts, and first of all then we check the 60. There are three frequency of the 60, and if we check the 60, and it shows 3 times. Then if we check the 20, then it shows 20. It means the age of the 60 there are 3 people, and age of the 20 there are 2 people. So for that kind of solution you can use the histograms or scatter chart. For the distribution purpose you can also use the box plot chart in Python. As you can see the diagram, the box it displays in box form, and the left side we have the minimum value, and then the quarter one Q1, and the median value, average value, then Q3, that's almost quartile 3, or we can say it's a 75%, and then maximum value. In case of the outliers, if there is an unusual comparison, unusual distribution, then it shows outside of this box. So in this example we have the 5 values 2, 4, 6, 8, 9. So for first of all we check there are 5 values, and the median value is the 6, then Q1 is the value 3, and Q2 is 6, and Q3 is the 8.5, and outliers there is no outliers. So in this program we have the minimum value 2, and that is the maximum value, and the first part this is called the Q1, and this is called the Q3, and this is called the median line, orange color, that is the 6th value. And in the Q3 we have, in Q1 we have the 3 value, this one, and the Q3 we have the 8.5 value, that is the 8.5 value. Now what is the outliers? So right now we have the 5 values, and if I add one more value, say 40, so this value is like unusual comparatively to the other values. So if I run this program, then I get this. So this shows there is a one value that is the unusual, or say -10, then one more dot. So there are 2 values, the one value is the negative and another value is the positive. So we can say these values are the unusual distribution. So guys, this was all about how to choose the right chart for the right solution. Please like the video and subscribe the channel. Thank you.